Okay, welcome back to part 2 of solution chemistry. This is where you will need a calculator, and we're going to be talking about just the main calculations that most chemists use in a lot of different chemistry applications. So there are 3 main calculations we're going to look at. The first deals with molarity, the second is dilution, and then we'll also talk about percent solution. So these are the 3 main types of calculations that you should be familiar with. Once I explain molarity, I'm going to come back and explain this picture, but this is how anytime you have a solution and you want to prepare a solution in the lab, this is really the process that you're going to want to follow. So what molarity is basically it is the concentration of a solution. There's a couple different ways that we can calculate concentrations, but the main one that we use in chemistry is called molarity. So molarity is noted by a capital M, and this just stands for the moles of solute. And again, the last video we talked about solute. That is what we are dissolving over the total liters of solution. Okay, so this is the entire solution that we have. So to calculate, we have to know the moles of the solute. So this still uses your knowledge of moles, and if we have grams, how to get that back and forth. So hopefully at this point that's starting to make a little bit more sense. And then the liters of solution. So how do we actually practically make a solution? So if I told you that you needed to, let's say you needed to measure 5 grams of sodium chloride and you needed to make 500 total milliliters. Okay, so obviously these are different substances here. When you find the mass, whatever that mass is, you actually weigh that out on a balance. We have balances with pretty high levels of precision in the lab. We also have these very precise volumetric flasks. You have not used these yet, but they are calibrated to be exactly that particular volume. So what you would do is you would have a certain amount of mass that you would measure out. You would then place that in the volumetric flask. You then use whatever solvent that you would need to make the solution. Again, most times we use water. In this particular case, you'd use ethanol. But you would add that to the solution, and that would start dissolving your solute. Now, again, you don't want to add all of the volume clear up to the line at first. You want to dissolve a little bit first. You swirl it around, and then you add enough of your solvent to get the meniscus to the mark. So again, this is a very calibrated, precise way that we have to make all different types of solutions. Even though you haven't had practice doing this, if you've ever made, let's say, a packet of Kool-Aid or lemonade or something where you had to follow a recipe. So let's say you had a packet of Kool-Aid. And if you have that packet of Kool-Aid and then you have a pitcher, you know that if you dump in that Kool-Aid into the pitcher, you're then going to have that sitting on the bottom. You need to add enough water to make it the right proportion. If you don't make it the right proportion, so let's say you don't add enough water or you add too much water, it's going to mess up the concentration. So again, we'll talk about that when we get to dilutions here in just a little bit. But this is the overall method that we use. So basically with molarity calculations, you just need to look at what you're given in the problem. If you're being asked for the molarity, that means you're solving for capital M, and that means that you should know the moles and the liters. So in this first example, it says a saline solution, which just means a saltwater solution, contains 0.5 moles of sodium chloride in exactly 100 milliliters of solution. What is the molarity? So that means that we're solving for M. So I should know my moles, which I do. It's the 0.05 moles of sodium chloride in exactly 100 milliliters of solution. Now, my formula has liters, so I need to convert milliliters to liters. Now, if you remember the stair step, base, drinking chocolate milk. If I have milliliters and I want to get up to the base unit, I move it 3 to the left, which means that's equivalent to 0.1000 liters. Okay, so if I just take 0.5 divided by 0.1, that means that I have a 5.0 molar sodium chloride solution. Now, what happens if instead of 100 milliliters, I put it in 200 milliliters of solution? Well, my molarity would just be 0.50 divided by now 0.2 And so if I look at that, that actually now gives me a 2.5 molar solution. So I still have the same solute. I'm still adding the water, but I'm adding more water. So what happens to my concentration is it becomes less concentrated. So it's really just the proportion of moles to my liters. So the next question says, how many moles of ammonium nitrate are in 335 milliliters of a 0.425 molar solution? So again, using this equation, now I'm asking you in number one to solve for moles. So that means I know my molarity, which I do, it's 0.425. That's then going to equal X over, again, I have milliliters, so even though our molarity equation is in liters, we have to always convert the milliliters to liters. So this would be 0.335 liters because my molarity unit is in moles per liter. So what I would do here is I would just multiply. So I would take 0.425 times 0.335. And when I do that, I get a total of 0.142 moles. And I have 3 sig figs for both of those values. So my final answer would be 3 sig figs. Now again, how useful is that to us in the lab having moles? It's not, but we can convert it to grams, which we'll see in this next example. And then we'll talk about how to actually make the solution. So this one says how many moles of solute, which would be calcium chloride, are in 250 milliliters of a 2 molar calcium chloride solution. So using the same equation, we're going to start with the same process and solve for moles. So I know that I have a 2.0 molar solution. I'm solving for moles, so we'll just put that as X over 0.250 liters. So when I do that and multiply to get X, I would get 0.50 moles. So I have half of a mole. So that's my first answer, but I want to know how many grams. So what I would need to know then is the molar mass of my solute or calcium chloride. So again, you can either use a molar mass calculator, or I will give you those embedded within the problem on the worksheet that you guys will see. If I just take a calcium plus 2 chlorines, that's 110.98 grams per mole. So again, either using the molar mass triangle or just setting up the conversion, if I multiply by the molar mass, grams per mole, that gets my moles to cancel. That would get me a total of 55.49 grams of calcium chloride. So if I asked you to actually make that solution, what it would look like in the lab is you would first, so if I asked you for the steps, you would first weigh out or measure 55.49 grams of calcium chloride. Then what you would do is you would transfer that to the volumetric flask, and I'll go back to that picture here in just a second. You would then add a little bit of water to start dissolving the calcium chloride. Once you've mixed some of that up, you would add enough water to the line, to the meniscus. And you would use a 250 volumetric flask since that is the total volume of solution. So they make all different volumes of these volumetric flasks. So again, here's that picture of what it looks like. So sometimes we don't have masses that we deal with. We actually already have solutions that are made. So another calculation that we can do is what we call a dilution. So a dilution is just reducing the number of moles of solute per unit volume, but it actually doesn't change the total moles of your solution. Now in this particular equation, you can have liters or milliliters as long as they're the same unit. So the best example is if you had some tea or you had some coffee that was really extra strong and you wanted to make it less strong so you could drink it, you would just add water or milk or something to it to make it less concentrated. That's basically all we're doing in dilutions. So if we look at this image here, I take something that is a concentrated solution. So sometimes we just have these concentrated solutions present in the stockroom. I then would take a certain amount of that and put it in a volumetric flask. So I'd only take a fraction of that, which we can calculate. And then what I would do is I would add enough water to the line to now make it less concentrated. And so you can visibly see that by it becoming a lighter blue solution. And we just have less moles per liter of the same solution. So the equation we use for dilution is M1V1 equals M2V2. Those are just my initial and final conditions. So if I look at this example, it says how many milliliters of aqueous 2 molar magnesium sulfate, so we can call that M1, must be diluted with water to prepare 100 milliliters, so this is the new volume that I want, of a 0.4 molar solution. So that is my new molarity. So I'm trying to find how much of that concentrated solution I need to make this new set of conditions. So if I go ahead and just plug in my values, I would have the 2.00 molar times V1, that's what I'm trying to find. I want to make it as a 0.4 molar solution, and I want to make 100 milliliters of that. Okay, so I know everything but my V1, and so if I just divide both sides by 2, that gets my molarity to cancel. So I would just take the 0.4 times 100 divided by 2, and that means I would need to take 20.0 milliliters of that concentrated solution. So if we look back up here at the picture, I would pipette out 20 milliliters. I would put that in a new flask. I would then add enough water to make 100 milliliters, which really means I'm adding 80 milliliters of water to make that new concentration. For dilution problems, just make sure that you are being careful with the wording, because sometimes it may say how many milliliters must be added or added to 100 milliliters. We'll talk about that in conferences and I'll walk through that. But just make sure that you really watch the verbiage of that. So the last type of calculation is a percent solution. These are very commonly seen, especially in like rubbing alcohol, hydrogen peroxide. So if you go to the pharmacy or the store, you'll actually see a lot of these that'll say 3% or 70% or 90%. So they're either percents by volume or by mass. The way you calculate these are just like you do any other percentages, so they're actually pretty straightforward. You just take the volume or mass of the solute over the entire solution, and that gives us our percent solution. Any of you that are planning on possibly going into the medical field, especially nursing and medications, a lot of times they will give you different percent saline solutions if they're giving you an IV. So pharmacists actually have to use these calculations to figure out how much of the medication, especially based on weight and height of the patient, they have to do these calculations to figure out what the actual percent is that they give the patient. So again, this is huge, especially if you're thinking about going into the medical field. You'll be using these quite a bit. So we're going to end this video with just these last two practice problems. The first says, what is the percent by volume of ethanol in the final solution when 85 milliliters of ethanol is diluted to a volume of 250 milliliters with water? So if I want to know my percent by volume, I need to know my volume of my solute. And so in this case, my solute would be ethanol. So I'm going to take the 85 milliliters of the ethanol. It's diluted to a volume of 250 milliliters with water, which means my total solution is 250 milliliters. I'm then just going to multiply that by 100. So if I take 85 divided by 250 times 100, that gets me a 34% solution of ethanol. Again, you could do this with a variety of different substances. The thing you need to watch here is if it says it is added to 250 milliliters of water instead of 250 milliliters total, you would actually have to add the two substances together. Number 2 says, what's the percent by mass when 3.5 grams of glucose are dissolved in 100 grams of water? So that's what I'm talking about here. We would take the mass of the solute, 3.5 grams of glucose, but then I'm adding that 3.5 grams to the 100 grams of water. So since I didn't say it's dissolved to make a total solution of 100 grams, since I'm telling you that the glucose is being added to the 100 grams, we have to add that as my final solution on the bottom. So if I just divide those values and then multiply it by 100, I get a percent solution glucose to be a 3.38% solution. by mass. Okay, so that's just a quick summary of the three main calculation types. The worksheet that I will have in Schoology, we'll walk through those and we'll work through those here this week. Please let me know if you have any questions.